Okay, boleh? Boleh kita mula? 3 jam hari ni ya. 3 hours. We did half an hour break in the middle after 2 hours. Okay, so basically group 2 and group 3 already finished chapter 4A. Okay, and we already started with transmission line. Okay, so I think I just go very fast on chapter 4A. Okay, so that we can cover the same path as G2 and G3. Okay, so transmission line, so basically there are 2 subchapters. Okay, subchapters A, subchapters A, which is cover from the introduction. Okay, so introduction, transmission line parameter, lump element, transmission line equation until distortionless transmission line is chapter 4A. So this one is chapter 4B. Okay, so this part is basically theoretical. Okay, so the last part from chapter 4 is basic calculations. Okay, just a basic calculations. Okay, so what is this transmission line? So basically there are 2 types of transmission line. Saya dah bilang itu kan? Okay, so kita boleh skip je lah, betul tak? Boleh Okay, boleh. So this one you can just read it by your own self. Okay, if you don't understand anything, just see later on. Okay, so 2 types, bounded and unbounded. Okay, example of transmission line. So basically we are dealing with a wired transmission line. Okay, bounded transmission line. So example is basically the coaxial cable. Okay, balanced wire coaxial cable. Okay, waveguide fiber optics. Plana is basically for wireless, more to wireless systems. Okay, so basically the most important thing in transmission line is to construct or to design the transmission line with accurate dimension and spacing, okay, according to the load or according to applications. And the second one, which is the most important thing, which is related to our subjects, is basically to have the good impedance matching. Okay, Z in is equal to Z L. Okay, with respect to the Z naught. Okay, so therefore, if we say that the most important thing in transmission line subjects, which is electromagnetic here, to cater the problem of good impedance matching. So therefore, basically transmission line constitutes from a lump element component. Okay, lump element component, basically we have R, L, C and G. Okay, R, L, C and G. Okay, so this is one lump element. Okay, and this is one lump element. 1, 2, 3 and 4, and this is the transmission line, which is the wire. Okay, transmission line. Okay, so this is where transmission line is situated, and this is the generator, and this is the load. So you learn electrical machine just now, right? So electrical machine is basically electrical machine belajar apa? Motor. Motor untuk apa? You learn electrical machines. So what is the purpose of motor? Motor is motor. Okay, what is the purpose of motor? Huh? Salah tak apa. What is the purpose of you learn electrical machine? Generate power. So what is the devices or component yang generate devices? Generate power. Motor. Dalam motor adalah rotor, stator, etc., winding, etc. So you learn that is basically how to generate the power. Macam nak generate the voltage and the current. Basically the device is basically the motor itself. So dekat sini lah. Dekat sini electrical machine. Oh. Okay. This one is basically the circuit. Okay. Circuit 1, circuit 2, lamp element. So you learn in terms of small things first. Small chunk of circuit. Okay. Then we combine. Okay. Load. Example of load. Example of load. Okay, R. Application wise. Example of load application wise. Lampu. Lagi? Aircon. Lagi? Speaker. Lagi? Ni low voltage. Kita nak high voltage. Consumer. Consumer human ke? Rumah, residential area, housing. So that is basically your load. Okay, apart from that, takkan keluar-keluar hydroelectric terus masuk rumah. Takkan like I said just now, from hydroelectric, okay, the one that you generate the high voltage, okay, I don't know how many watt, how many kV, okay. So what is basically the load after the generations of the hydroelectric? Takkan terus masuk rumah. Distributions. Dalam distributions tu ada apa? Distribution center ada apa? Ada? Transformer. Ada lagi apa lagi? Step up, step down lagi? Lagi? Mesti ada generator balik, betul tak? Okay, so dia akan, nampak tak? Repeated. So dia akan batang daripada generator, which is for medium power. Belajar power system engineering kan? Transmission line for how many kilometer untuk high power, betul? Medium power, betul? Low power, betul? So it reflects on transmission line. How do you basically design the transmission line in order to meet the requirement of the load? So load can be low power, medium power or high power, high voltage. Okay, awak seronok je high voltage, generator, hydroelectric. Okay, so that is basically transmission line came into the actions. Okay, basically you ask why we have to learn electromagnetic. Okay, next questions. What is conductance? Transmission line basically constitute from R, L, G and C. What is G? Conductance, okay. Insulations, okay. G is equals to what? G is equals to? Okay, good. G is equals to 1 over R. That's why ada G kat sini. That's why ada R kat sini. That's why dalam elemen ada R kat sini. Okay, nampak tak? So baru make sense benda tu. Bukan saja-saja kita letak L, R, G and C. Okay, one more question. Admittance. This is conductance. Afterwards, we will learn admittance. Ada one more. Admittance. Y, which is 1 over Z. What is Z? Impedance. Okay, nampak tak relationship? Semua tu dalam circuit. Okay, for transmission line, electromagnetic, we just have to use the value. But then you have to know what is conductance, what is admittance. Okay, what is R, what is L, what is C. Okay, last question. Tak ada lagi soalan. Why in transmission line, we have to use L and C? Why in lump element circuit, we have L and C? Why do you learn in circuit 1 or 2, 3, ada yang belajar sampai 3, you learn lump element, you learn circuit constitute of R, L and C. Cos AC. Okay, lagi? Which part yang AC? Good. Bagus.
Supply.
Supply. Okay. But which part basically related to the AC? R, L and C? Which part related to AC? Semua ke ataupun L and C? Semua. R, L and C. Semua. All. Semua faham semua? Semua means all. R, L and C related to AC. Okay, DC? R only. Oh, dah pening lah. Nanti jumpa Dr. Nick Dr. Leong ke Dr. Azra ke. DC? DC is R or L, R or C. Betul? Tak pasti. Tak apa. Betul? Tak pasti. Okey, tak apa. Betul? Okey. Soalan yang last kali untuk memeningkan awak. Okey, why AC have to involve L, C and R? Why AC? We must have L, C and R. Your friend said DC, R and C or R and L. Tapi AC mesti kena ada tiga-tiga. Pukul 10 tak ngantuk dia kan. Nanti pukul 12 baru kita masuk calculation. Okay. Tak tahu. Okay, lagi satu soalan. What is the difference between resistance, inductance and conductor? Resistor, inductor and capacitor. Apa beza? Resistor? Dr. Leong mesej saya. Student FIP dia tanya, what is resistance? Student tak ada jawab. Tapi ada jawapan. So saya beritahu. So I said, sorry. Dr. Nick, Dr. Leong, okay, message me saying that final year students, okay, final year project, came and see Dr. Nick, Dr. Leong, okay, and then Dr. Leong asked the students what is resistance, okay. They gave a few answers, but basically the answer is wrong. Okay, dia bagi few jawapan lah. And then I said to Dr. Leong, I said, basically the student is good, at least they have an answer, rather than you just, senyap, without any answers. Okay, so patah balik. What is resistance? What is the difference between resistance, inductor and capacitor? Capacitor, charge and discharge. Inductor? Stop current. Store current. Which one is store current? Which one is storing current? Inductor only. Inductor and capacitor.
Inductor stores in magnetic field.
Inductor, capacitor, store current lah, or energy. Okay, resistance,
Valve.
valve. Resistance, limit current. So how do you rate I and C, which is storing energy or current in AC
Oh,
circuit?
dia AC dia ada different voltage, dia vary.
Different voltage.
So maybe kapasitor dengan induction tu dia boleh stop the vary yang tak tetap, voltage yang tak tetap dari AC.
Okay. Boleh? Do you understand? Understand? Okay. So taklah salah, tak tepat. Okay. So resistance, yes, limit current. Okay. But resistance, it dissipate heat. Okay. It dissipate heat. Okay. Inductor capacitor, they dissipate heat tak? Inductor capacitor, they don't dissipate heat. Okay. But inductor and capacitor, there are two components, betul tak? Real and imaginary. Okay, what is basically the purpose of imaginary? What is the purpose of real and imaginary punya axis? Belajar kan? Real axis, imaginary axis for inductor and capacitor. And you have reactive power, apparent power. Power leads, current leads voltage by 90 degrees. Kenapa current is better leads voltage by 90 degrees? Kenapa? Why is current better leads voltage by 90 degrees? Why we don't want current lags voltage by 90 degrees? Power factor. Power factor tadi lah, lead and lags. Power factor kita belajar dekat power system engineering. You want higher power factor. Why? Tu belajar dekat power system. Okay. So L and C, they're the real part and imaginary part. Imaginary part is basically for storing the energy. Okay. Imaginary part is basically for storing the energy. Okay. And why AC? Because oscillations, propagations. Okay. Kita ada phasor, real dengan imaginary. So that's why kita guna L and C as compared to R. Okay, so that's why lump element, you learn circuit 1, circuit 2, yang ada lump element LC is basically to apply to the transmission line, to apply to the power system analysis ke engineering later on. Untuk belajar bus bar lah something kan. Semuanya related. LC, LCR, LC, LCR. Tu circuit tu penting. Kan orang kata circuit susah lah, tak payah ambil circuit lah. But then the basics came from the circuit. Okay, good enough. Okay, come back to transmission line. Okay, transmission line without losses is just a straight line. Okay, it's just a straight line. Okay, without any component. But basically, it's very it's not possible. Okay, to have only just straight line transmission line without any resistance, capacitor, and inductor. So basically, this is the representative or equivalent circuit for transmission line, which is related to the circuit. Okay, so I don't want to derive any circuits in transmission line. Kita akan just plug and play, use the values sahaja. Okay, but the main thing is basically you understand the basic. Why you have to learn circuit, why you have to learn electrical machine, why you have to learn power. Okay, why later on ada renewable energy. Okay, one source of power basically. Okay, why you have to learn electrical machine and etc. Okay, so role of wavelength ni afterwards. Okay, transmission line equations. Okay, time to basics. Okay, transmission line equations. So basically there are two important parts, which is propagation constant. How do you pronounce this one? Gamma. Gamma. Okay, propagation constants and attenuation constants. Okay, soalan lagi. What is the difference between propagation and attenuation? Awak sendiri baik tak nak Google ke? Handphone kan ada lens. Oh, lens. Pakai line apa ni? Cellcom. Line, what types of mobile operator do you use? Handphone, mobile operator, you use Cellcom, Maxis. Mobile is okay here? No. Sama je, semua sama je. Maxis? Sama je, baru. Dalam ni sahaja ke ataupun di mana-mana sahaja? Okey, di luar yang mana lagi bagus? Cellcom? Ya ke? Penipu betul lah. Tak apalah, kita abaikan. Okay. Nanti dia lagi panjang cerita dia. Sebab saya memang orang mobile, nanti dia cerita lagi panjang. Okay. What is the difference between propagations and also attenuation? Propagation. Tak apa, nak tengok handphone boleh, tak ada masalah. Sebab semua sekarang di hujung jari. Hujung jari bahasa Inggeris apa? All in your fingertips. You can Google. Okay, propagation and attenuation. What's the difference? Apa beza? What is the difference between propagation and attenuations? Kenapa? Why propagation constants? Gamma equals to attenuation constant and phase constant. Angguk-angguk juga. Angguk-angguk, giling-giling. Why? Siapa nak makan boleh makan. Siapa nak minum boleh minum. Siapa nak pergi toilet boleh. If you want to eat, if you want to drink, same like control system, since you're in the subjects. If you want to sleep for a while, so can. Okay, propagation. Propagation, AC, sine wave, cos wave, propagate, betul? So it propagates according to time, betul? F equals 1 over T, F equals to 1 over T, T equals to 1 over F. Okay? So when you're talking about wave, so it propagates, oscillate. Propagate or oscillate. Attenuation, something happens to the signal. Okay, something happened to the signals, which means that another signals coming in. Okay, so therefore the original signal attenuates. Okay, maksudnya ada something happen dekat sini tu, ada loss. Okay, so the losses basically came from two sources. It's either from environmental or from inside the cable itself. Okay, inside the cable ada dua jenis, two types of propagation, attenuations. It's basically the connector. Okay, the connector. This is the connector. This is the transmission line. Okay, you have to splice the transmission line accordingly, suitably, so that connections between the transmission line and connector is in order. So there is no losses. Okay, so kena design lah. That's why tadi dimension and spacing, right? Plus the connector. Okay, second one must be impedance match between between the transmission line and also the connector, and also the load, which is the microphone. Okay, that's why transmission line earlier on is basically on dimension, spacing plus impedance matching. Okay, spacing, connector, and also the impedance matching of the load. Okay, so that's why gamma is equals to alpha plus j beta. Okay, propagations of the wave must include the attenuations and also the phase, sebab ada L and C tadi. Okay, so therefore alpha plus j beta is equal to R plus j omega L, okay, times by G plus j omega C, which is related to the circuit, which is the dalam element earlier on. Okay, square root. Okay, so I don't want to derive this one. Dia panjang. Dalam konteks dia panjang, dia buku surat. So kita guna je for the sake of transmission line electromagnetic. Okay, power system nanti akan ada rasanya. Okay, attenuation constant, alpha and beta. Okay, so apart from alpha and beta, we have another one more constants, three more constant, which is, this is gamma, epsilon and mu. Okay, mana datang? Where basically the constants epsilon, mu ni datang is basically on the material of the transmission line. Okay, different material give different refraction and refracted angle of the signal. Okay, reflection, reflect pantulan, refract pembiasan. Kita tak nak pembiasan. We don't want refractions. Okay, the signal will be moving out from the transmission line. Okay, kita nak reflections with certain degree of signals lah. Okay, so contoh transmission line, so kita nak reflect macam ni. Dia ada angle dia. Okay, kita tak nak dia datang sini, kena transmission line, dia refract keluar. Ini further lah, tapi nak bagi tahu the main of mu and also epsilon is basically on the material itself. Okay, how to construct your transmission line. Tapi kita guna je coaxial cable, habis cerita. Tak kisah dalam tu ada apa, guna apa. Okay, so this is this one. Okay, table ni ada mu, ada epsilons. Okay, so this is basically the parameter being used. Okay, so for you just guna sahaja, tak ada masalah. Okay, so transmission line, this is also the equations. V equals to F over lambda, omega over beta. Okay, beta the phase constant just now. V is basically the phase velocity. Okay, the velocity of the wave. Okay, the accelerations and etc. Okay, Z naught R plus J omega. So this is basically already seen in your circuit. Okay, so there are basically three model of transmission line: lossless, distortionless, general transmission line equations. Okay, so kita masuk calculation wise untuk lossless, distortionless dengan general. Tadi tu semua teori. Okay, so lossless propagations means that no loss. 5 watt output pun dapat 5 watt. So that's meant by lossless propagations ataupun lossless transmission. Okay, so when there is no loss towards the transmission line, R equal to 0, G equals to 0. Simple. Okay, R equals to 0, G equals to 0. So therefore this equation dia akan simplify sebab R equal to 0, G equals to 0. So hanya tinggal yang ini sahaja. G omega F times by G omega C square root. Okay, yang lain-lain ni, this one is basically the same. Okay, Z not equals to square root of L over C, yang tu ada derivation dia. But then for you just use it. Okay, boleh. So the main important thing, R equals to 0, G is equal to 0. Logic lah, because G is equals to 1 over R, right? Okay, so lossless transmission line, beta equals to, so this one also omega, just guna je. Yang penting this one. Okay, lambda equals to Vp over F. So basically we are using V or we are using U. Velocity sama je. Some books using U, some books using V. So means velocity of the wave. Okay, boleh. Relative permittivity of insulation material, conductor. Okay, kalau epsilon lah. Kalau mu, permeability, magnetic field. Okay, saya tak nak sentuh benda tu. Okay, example 1. You have slides, right? Ada slide kan? Saya nak buka words, nak contoh yang atas words. Nak salin ke? Nak salin? Tak nak. You want to copy these questions? No, okay. So we go one by one. Okay, slowly. Tapi saya rasa guru awak ni laju. Semua dah terror. Okay, so questions. You need to find inductance L and also C for lossless transmission line. Okay, given 70 ohm, so this is basically R or basically Z naught lah. Okay. G 1 gigahertz is frequency. 3 radian per second. Phase constant. Alpha ke beta? Beta, good. Okay, so pull out the parameter first. Okay, R ataupun Z lah, sebab R equal to 0. Okay, so Z. Okay, tapi saya biasa guna R ataupun Z not. Is equals to 75 ohm. Okay, frequency equals to 1 gigahertz. Okay, beta equals to 3 radian per meter. So basically all in meter. Okay, length, distance is code in meter. Okay, so we need to find L, we need to find C. Okay, we know that Z naught is equals to R naught, which is equals to square root of L over C. Equations in the slide. Saya bawa keluar je. Okay. So this is equation number 1. So equation number 2, sebab given beta, so beta is equals to omega square root L C. So number 2. But now we need to find only L and only C. So how do we equate these two equations so that variable is only one? Kita nak buang salah satu. Nak buang L ke nak buang C? Okay, salah satu. Saya nak buat? Saya nak buat 1 dan 2. 1 divide by 2. Boleh tak? 1 divide by 2. R naught divide by beta. R naught or Z naught lah. Kita boleh guna Z naught atas ni. Kalau tak nak guna R naught, Z naught. Sebab R equals to 0, betul? Okay. L over C divide by omega square root LC. Tara.
Boleh substitute tak?
Substitute boleh juga. Mana-mana pun boleh. As long as you get the answer. Boleh bertanya, boleh buat. Nanti boleh tunjuk kat depan. Substitute. Sama je. Okay? Follow? Okay, now. Macam nak buat ni? Square root ni. Aduh, square root ni. How do you simplify this one? Okay, so this is basically equals to L over C times by 1 over omega LC. Betul tak? Kita pusing je lah. Itu darab, itu bahagi, betul? Ini bahagi, kan? So kita pusing je, dia akan jadi. Okay, saya dah faham kot. Okay, good. So sama juga, like I said earlier, saya tak suka, I don't like the square root. So kita times by square root, times by square root, times by square root. Kalau rasa nak substitute lagi mudah, substitute. Okay, yang ni saya tunjuk satu persatu jalan kerja, sebab ada yang tak boleh nak follow the substitution. Okay, so Z naught beta square root. So this one tinggal L over C times 1 over omega square root LC. Okay, kita boleh potong lah L dengan L. Okay, follow? So square root of Z naught beta equals to 1 over square root omega C square. Hai, saya tak suka juga square root ni. Saya darab balik dengan square root. So darab square root, so darab square root. So akan jadi Z naught over beta equals to 1 over omega C. Tara. So boleh cari C lah. Betul tak? Z naught dah ada, beta dah ada, omega dah ada. Okay, so this one kita akan dapat rearrange. C is equals to C is equals to C is equals to C C is equals to
1/.
beta. Ni darab ke atas, ni darab ke atas. Yang ni bagi ke bawah.
Beta
Omega
omega no.
dapat. Okay, masuklah value. Beta equals to 3. Omega 2 pi F. F is berapa F?
1 giga.
Giga. 1 darab 10 kuasa 6. Betul. Z0 75. Betul. Okay. Tekan calculator. Berapa dapat? Tekan calculator. C. C is equals to 6.36 pico. Dapat? 6.36 pico. Dapat? Okay, good. 6.36 pico. Alright. Okay, C settle. Okay, L pula. Macam mana kita nak buat L? C dah ada. C dah ada. So, kita boleh guna value C. R dah ada. Okay, so using this equation, kita guna equation ni. Okay, so Z0 equals to square root of L over C. Okay, so L is equals to R0 Z0 square. Okay, so Z0 75 square. C kita dapat 6.36 pico. Habis soalan satu. Okay, how much did you get? Ini boleh macam dapat Z0 square over C. Z0 square times C. So square root bawa sini jadi square. Okay, berapa dapat? L? Saya tak ada jawapan. Berapa jawapan? Yang saya ingat nano kot. Nano Henry. How much did you get? Calculator kena bawa Kosong point 0.36. 0.36 ada prefix dia berapa? Darab 10 kuasa berapa? Oh,
Betul tak?
0.36 je.
No. Kuasa negatif 9.
0.36
0.357 kuasa negatif 9.
0.357 nano lah kan? Farad per meter. Okay, sama juga. Farad per, tadi inductor Henry. Farad mana pula? Henry per meter. Allah. Farad per meter. Okay, boleh? Nak ambil gambar kan? Silakan. I will not post these solutions in the e-learning because I expect you to do the exercises with me line by line. Okay, so kalau nak ambil gambar 1, 2, 3. Nanti bawah tu ambil signature saya. Okay, boleh? Soalan? Questions? From my right, ada soalan? Do you have questions? The backbenchers follow. Belakang tu siapa? Hazim Saya akan dapat PS saya bukan. In the middle, belakang. Boleh? Boleh? Yang belakang baju merah. Boleh? Okay, belakang Jeremy kan? Okay, follow. Depan, saya tak ingat nama. Memang 3 sekawan, 7 sekawan. Boleh? Soalan? Tak ada? Okay, tak ada soalan. Cuba buat soalan ni.
Doktor. Yang jawapan dia 35.
Jawapan dia 35.
35.
35 berapa? 0.775. Nano pico. Pico Henry.
Betul.
Ambil gambar sekali lagi. Okey, jangan ambil gambar lagi. Jangan. Okey, ambil gambar sekali lagi. Ni salah. Maka okay, ambil gambar lagi. Okey, settle. Dah? Okey, kalau sudah, take a look back at the slides. There's one questions. Example 2. So can you do example 2?
InsyaAllah.
Tolong buat. Saya nak jawapan je. Impedance Z0, beta, and also frequency. Okay, so before I forget, okay, in test or in test lah, transmission line is not included in final exams. Okay, we are only given you this equation and this equation. Okay, you have to derive by your own self in order for you to get these equations and also this equation. Kejam sikit lah. Sikit je kejam. Okay, kejam-kejam tapi masih sayang. Okay, exercise. Lima minit. Sekejap je, masuk je value dalam equations. Okay. Jawapan dah ada dah dekat slide next tu, saja nak suruh awak buat. Jawapan dah ada. Okay. Tekan calculator. Sebab ada yang tekan calculator pun salah. Jadi tekan calculator salah kan jawapan. Pico nano beza tau. RM1,000 dengan RM1 beza. 10 kuasa 3 dengan 10 negatif 3 MYR. 10 negatif 3 10 negatif 3 MYR. Duit Malaysia maksudnya berhutang. slide? Atau berbeza? Abdullah, right? Abdul Aziz. So, friends call you Abdul Aziz. Okay, jawapan, answer. And sebenarnya ada je answer dekat sini. Dapat sama tak? Do you get the same answer? C is equals to 90.9. L is equals to 227 nano. Dapat? Sama je. Substitute in the equations yang kita dah derive tadi. Dapat? Dapat tak? Tembus ke belakang terus ni. Abdul Aziz, do you get the answer? Satu minit lagi. Dapat ke tak? Tak dapat.
Dapat berapa?
Dapat?
Dapat 8.
Sepatutnya dapat lah. Dapat? Tak dapat? Dapat? Tak dapat? Dapat ke tak? Tak dapat? Mana? Masukkan je value tu. C sama beta over. Kau nak kena derive balik, tak payah derive kan? Just use the same equation earlier on. Okay? Just use the same equation earlier on. Okay? Tak payah derive daripada awal sampai akhir. Guna je equation ni. Just use this equation. Okay? And this equation. Ini. Okay? Kita dapat? Okay, dapat. Sebelah kiri dapat?
Tadi guna substitution ke?
Dapat. Sebelah kanan?
I kira I dapat nombor
Dapat.
sama tapi
Okay.
power dia lain.
So, it was supposed to be another one more exercises. Okay, so boleh ambil jawapan dia. Nanti you take the answer and then you can do it by your own self. Okay? Sebab saya nak masuk distortionless. Okay? Finish it up until distortionless. Then kita stop, break half an hour, and then another 1 hour.
Sekejap.
Okay?
12 kan?
Boleh?
Betul lah kan? I pun tadi buat salah dekat situ.
Kejap. I dah gelau lah. Betul.
Dapat? Okay, good. So, please take the answer for the exercise number 3. Ini was supposed to be examples lah. But it's the same like the first example. Sama je. Okay? Abdul Aziz, do you get the answer? Okay, good. Okay, next. The second one of types of transmission is distortionless line propagations. Okay? Distortionless line is basically it's basically the same but not equally the same as lossless line. Macam mana cakap? Macam tu lah. Okay? Distortionless line, attenuation constant is frequency independent. Phase constant is linearly dependent on frequency. R and G, there is a value for R and G. Okay, lossless, R equals to G equals to 0. But for distortionless, G over C is equals to R over L, which is equals to G equals to RC divided by L. Nak cari conductance. Okay. Sepatutnya was supposed to be G is equals to 1 over R, betul? R equals 1 over G. Okay, distortionless ni dia beza sikit. Okay, a little bit different. Okay, the application for distortionless line is basically for your telephone system. Tak kita balik cari kat Google. Okay, sebab kalau nak cerita nanti dia panjang. Okay, so propagation constant alpha plus G beta. So because we have the value of R and G, so therefore R plus G omega L, G plus G omega C. Okay, so this is the same Vp equals to omega over beta. Omega, tadi ada yang tanya, omega memang 2 pi F. Okay, F frequency. If not given frequency, is equals to 1 over T. Okay, so R0 plus J omega notes. Okay, nanti kita akan derive benda ni. Okay, so example number 3 for distortionless. Okay, so distortionless we have to find 4 component R, L, G and C. Okay, lossless only L and C. Okay, so we need to find R, L, G and C. Okay, boleh? So saya nak tutup slide. Saya nak buka words. Ni. Ini jawapan, kira sendirilah. .2 picofarad. 334.2 nano Henry. Apa? Dah tua, dekat tak nampak, jauh tak nampak. Okay, example 3. Boleh? Distortionless. Kita pergi ni, lepas tu kita berehat. Okay, distortionless. Value apa? What the value given? Z0 equals to 75 ohm. Betul? Lepas tu frequency equals to 100 megahertz. Lagi? Habis. Alpha, betul? Alpha ke beta?
Alpha.
Alpha, okay. Alpha equals to 15 milli
Ya.
15 milli. Okay, VP betul? VP ataupun U sama je. Okay, some books using U, some books using V. V is basically the velocity. Okay, 0. Berapa? 0.5 C. Unit dia meter per second. So basically all the unit is meter. Okay, C is constant, the speed of light. Okay, C is constant, the speed of light, which is 3 times 10 to the power of 8 meter per second. Halaju cahaya 310.8. Okay, so the value that we need to find is basically R, L, G, and C. Okay, so the first equations, G equals to RC over L. Okay, marah ni dia. Okay, first equation. Second, Z0 equals to R0, which is equals to, sama juga macam lossless tadi, L over C, square root of L over C, square root panjang ke bawah. Okay, so this is 1, this is number 2. Okay, alpha equals to, I've got dalam slide, alpha equals to R times square root C over L, betul? Okay, semua dalam slide. Okay, this one, kalau I try to rearrange ataupun simplify the equations here. R divided by Z naught. Boleh dapat tak? Sebab this one Z naught equals to square root of L over C. Okay, so 1 over Z naught is equals to square root of C over L. Oh, pandai-pandai. Jiwa ni memang semua laju mak. Sejam 10 minit boleh ambil distortionless. Tak sia-sia lah saya ambil grup jiwa ni. Sebenarnya okay, tengok solution saya. Okay, you can also use the solutions in the slide. Okay, saya rasa this one is preferable. Okay, as far as you understand, so boleh guna slide ni, pun nak guna slide dulu. Okay, I do all. Okay, sabar-sabar jangan ambil gambar lagi. Tak habis lagi, panjang lagi. Okay, next. So we get alpha equals to, okay, alpha equals to ni saya padam. Oh, patutlah ambil gambar tadi ya. Siapa tak ambil gambar? Habis ni. Okay. So therefore, this one alpha equals to R over Z naught. So R is equals to alpha times Z naught. Okay, so bolehlah substitute the value. Alpha 15 dB, Z naught, what was Z naught? 75. Okay, so you will get dapat kan? Betul kan? 1.125 ohm per meter. Ohm per meter. Ohm per meter. Ohm bahagi dengan meter. So nanti kita akan tengok satu lagi exercise afterwards. Okay, boleh? Okay, good. Okay, next. Kita nak guna apa ni? Kita nak cari apa? R dah dapat slash L, G and C. Kita guna V equals to omega beta. Beta kita tak ada kat K, tapi beta is equals to, sorry, V is equals to 1 over square root of LC, betul? Dalam slide V is equals to 1 over square root of LC. Okay, so kita nak cari, okay, kita nak equipkan the equations. Okay, L dan C kita nak buang L tu ataupun kita nak buang C. Okay, V is equals to 1 over LC. So is equals to 1 over square root of L times by square root of C. Betul? So square root of C kita boleh ambil daripada sini. Okay, so kita akan dapat 1 over square root L times by Z naught over square root L. V sini. Square root times square root akan dapat 1 L. Ni square root times square root kan. So akan dapat Z naught over L. Magic. Okay, terpulang. Nak guna cara substitution pun boleh, nak guna cara pun boleh. Jadi dapat jawapan yang sama. Okay? Boleh? Mana datang ni? Daripada sini, atas. Ini. Z naught sama dengan L over C, betul? Okay. Z naught squared sama dengan L over C. Square root darab sini akan jadi kuasa 2, betul? So Z naught squared equals to L over C. Okay, so C sama dengan L over L over Z square, betul? So kita buanglah Z naught square ni. Kalau tak nak buang tak ada masalah. So dia akan jadi ikutlah square root C sama juga dengan square root L over Z naught. Betul? Allah. L over C. Okay, square root C sama juga dengan square root L over Z naught. Balik je lah. Ni kan 1 over square root C. Ni kan jadi Z naught over square root L. Pusing. So masuk kat sini. Okay, boleh. Saja nak pening-pening awak. Okay. Kalau boleh guna cara lain yang lebih, do you have any other substitutions method? Nak guna boleh. Siapa yang dah buat nak share dengan kamu boleh. Okay, so V boleh? 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 Abdul Aziz, you have another easiest way also, we can share afterwards. Okay, so substitute the value. V is equals to Z naught over L. So Z naught, okay sorry, kita nak cari L. L is equals to Z naught over V. Okay, Z naught is equals to 75. Okay, our V is basically 0.5 times 3 times 10 to the power of 8. C tu 3 times 10 to the power of 8. Fix. Hal laju cahaya, speed of light. Google, speed of light. Google. Speed of light, C. Okay, jawapan 500 nano Henry per meter. Okay, cut. Susah matematik ni.
Akan tak ada minit.
15 minit kan. Okay, boleh? Kiri boleh? Semua dah tunduk aja. Ngantuk kan? Sikit lagi. Oh, pukul 11. Semalam kelas saya 12-1. 1-1. Sorry, 12-2. Semua orang macam tu je lah.
Micro ke? Ha? Macam micro ke? Nano.
Okay, G berapa? G3. Allah. 3-4 tu saya dah tak larat lah. Atas sikit. Nantilah baru ambil gambar. Besar kan lah ni? Besar sikit lagi. Okay, Sat, 500 nano Sat. Contoh. Okay. Awak tak kat gambar satu dah lah, masuk dalam ni. Mana Sat kau? Dah kan? Dapat pahala banyak. Kalau saya cakap kat anak saya, pahala turun dari langit jatuh ke debu. Macam tu cakap kat anak saya, terus anak saya nak buat. Per meter, ya, per meter. Pahala tak nampak kan? Kalau duit jatuh dari langit. Takkan saya nak balik duit kot kan. Okay, next. Okay, R, G. Okay, habis selingan. Sorry, ini apa? L. Okay, L habis dapat. Okay, G is equals to RC over L. So R dah ada, C dah ada, L dah ada. So just substitute the value. Masuk je value. Okay, so you will get 2 times 10 to the power of minus 4. Okay, Siemens per meter. Okay, and last is basically C. C is equals to C G dah. R L. Sepatutnya kita cari C dulu kan. Awak pun ni je. Okay, sorry. C is equals to L over Z naught square. Yang ni tadi ni. Okay, sorry. Okay, L over Z naught square. So you will get 88.89 picofarad per meter. Okay, so jangan dapat 5. Okay, equation ni dan equation ni. Mana dapat equation ni daripada sini. Okay, balik buat sendiri. Okay, go back and do it by yourself. The derivations. Saya ni ke kiri kanan depan belakang lah. Okay, so rearrange. Okay, all the equations. Okay, in your hostel, better still. Okay, so tak gambar, kita gambar ini. Settle. Oh, nampak kan? Tak nampak. Okay, inilah boleh nampak. Nampak semua. Okay, dan okay, there's one questions. Kita buat dulu soalan tu boleh sebelum kita berehat. Dah, habis gambar. After this, taking picture? No. Okay, done. Okay, next. This is exercise for distortionless. Okay, extra question to be asked is basically the lambda, which is the wavelength. Okay, wavelength lambda. Okay, in transmission line, the length of the transmission line is basically calculated in lambda. Okay, in transmission line, okay, the length of the transmission line. Okay, the length of transmission line is basically, the unit is basically in lambda. We use lambda. Okay, we use lambda. We're not using meter or kilometer. Kalau orang com engineering, engineer dia akan guna lambda. How many lambda is transmission line? Okay, so that's why the equations and the questions here ask you lambda. Okay, so we will use the lambda in transmission line using Smith chart later on. Don't worry. Wavelength. Wave. Oscillate kan? Wave lah. Length, panjang. Wave. Salin jawapan je. Tak payahlah salin jawapan. Okay, dah habis. Kenapa perlu salin bila adanya kamera yang canggih? Kadang-kadang kita beritahu juga kan, lupa kamera tak nampak. Letak dalam group. Ada je buat. Okey, dah habis salin. Siap, salin. Okay, so towards the end of the tak ada. Tak jadilah. This one saya nak awak take a piece of paper, boleh? Saya nak awak hantar piece of paper and then you have to submit this exercise. Kejap. Okey, kita tukar. Tukar soalan. Ambil soalan ni boleh tak? Tutorial questions. Okay, tutorial questions. Distortionless. R, L, G, C and wavelength. Okay, RL, GC and wavelength. Yeah, submit.
Bila nak belajar kalau tanya orang.
Don't forget to sign your attendance. Attendance. Attendance dekat mana? Where is your attendance? Attendance. Dah. Belum. Rentas benua. Guna transmission line. Transmission line boleh guna utaya. Transmission line 1. Lam elemen yang kedua. Lam elemen ketiga wanida. Oh, ni orang guna lagi. Oh, kena pecah. Balance line. Okay, you have to be careful. Here is a 30 milli nanometer. This is 0.4C. 0.4C.
Saya.